Number 17, sorry. 5 boys and 4 girls are to be seated in a row in such a way that all the boys are seated alternatively. That is, boy, girl, and so on. This can be done by taking, very simple. For this, what we have to do is, the answer is 5p4. In how many ways can the 5 boys be arranged? Into, in how many ways can the 4 girls be arranged, which is 4p4. So 5p5, sorry, it is 5p5 into 4p4, which is nothing but 5 factorial into 4 factorial, which is 2880. Okay, you'll have to memorize certain things. Now, number 18. From 5 engineers and 4 doctors, in how many ways can a committee of 4 be formed such that it contains, without any conditions, that is, the committee can comprise of any number of engineers or any number of doctors from the given group. So here we're talking about committee. Okay, we are not concerned about whether the 4-person committee is arranged as 1 engineer, 1 doctor, 1 engineer, 1 doctor. No, we are concerned just about a group. From 5 engineers and 4 doctors, we are taking 4 people and forming a committee. So order does not matter. Arrangement is not a question. So this is a question of combination. So here, when they say no conditions, means from the total 9 people, we have 9 people, 5 engineers. So that arrangement, in how many ways can 4 boys be arranged? It is 4 factorial or 4p4. This would be 3p3, which is 3 factorial, into 4p4, which is 4 factorial, which is 144. Okay, I hope you're getting the idea. Number 16. 4 boys and 2 girls are to be seated in a row in such a way that all the boys and all the girls are seated together. So all the boys and all the girls are seated together. That means we cannot, these are treated as 2 people, right? 1 and 2. These are always together, these are always together. In how many ways can you arrange it? 2 factorial. The 4 boys can be arranged in how many ways? 4p4, right? The 2 girls can be arranged in how many ways? 2p2. And these 1 and 2 big groups, or 2 people as we can think of it, can be arranged in how many ways? 2p2, which is 2 factorial. So it is 4 factorial into 2 factorial into 2 factorial again, which will give me 96. Hello everybody, this is me Vinu Venkatesh on behalf of Sai Education for Competitive Examinations. So we're going to continue our lecture on permutations and combinations. We finished number 14, so let's start number 15. I hope you guys are practicing. 4 boys and 2 girls are to be seated in a row in such a way that all the boys are seated together. So as we discussed earlier, we have 6 people, boy 1, boy 2, boy 3, boy 4, girl 1 and girl 2, right? So such a way that all the boys are seated together. So this is the group of people. So how do we solve this? Where are we? Number 15, right? So if all the boys are to be seated together, then this is treated as one entity, right? This is one way of seating them, or you can have girl 1 here, all the 4 boys, and girl 2. So these are 2 different people and this is treated as one person. So in how many ways can we arrange this 3 people, like what we discussed right now? 1, 2 and 3. 1, this whole thing, 2 and 3, it is 3 factorial. But since all the boys are obviously different, we can also arrange, they have different arrangements among the boys. It can be B1, B2, B3, B4. It can be B1, B4, B3, B2 and so on. So that 5 engineers plus 4 doctors, we have to choose 4. So it is 9C4, which is nothing but 9 factorial divided by 4 factorial into 9 minus 4 factorial, which when simplified will give you 126. Okay, this is a formula, we saw that. Next, no doctors. That means the committee should not have doctors. So how many people do we have to choose from? 5. And how many people should we choose? 4. So it is 5C4, right? They have just done this for understanding. 4C0 means from 4 doctors we are not choosing any. So you can write it like this, but the answer will be the same. Okay, this is for just to be correct by definition. If the committee contains all doctors, that means how many doctors do we have? 4. From that we have to choose 4. So it is nothing but 4 choose 4, which is 1. We can only have one way of choosing 4 doctors. Obviously, from the 4 we are taking all 4. At most 1 doctor. Okay, so this can be written as, okay, so at most 1 doctor means it can be 3 engineers and 1 doctor, which can be solved as 5C3, 5 engineers choose 3 into 4 doctors choose 1, or it can all be engineers because they want maximum 1 doctor, right? So it can all be all engineers. So it will be 5C4 into 4 choose 0. So this plus this. Why is it plus? Because we are saying it can be this outcome or it can be this. And remember we said or means plus. So when you solve it, you will get 45, right? So first understand the question. At least 1 doctor. How can we write it? Try doing it like this. At least 1 doctor means of the 4 places, it can be all doctors, which can be written as 5 engineers choose 0, that is no engineers, into 4 doctors choose 4, or 3 engineers and 1 doctor. So 5 choose 3 engineers into 4 doctors choose 1. So or means plus. So or here again you have to add each outcome plus the other because it is one outcome or the other. Or we can have 2 doctors and 2 engineers. So it will be 5 choose 2 into 4 choose 2. Or we can have 1 engineer and 3 doctors, which will be 5 choose 1 into 4 doctors choose 3. When you add each of these outcomes, you will get 121. Where is that? Okay. Next, having same category. Having same category means the 4 places or the 4 people in the committee are either or all engineers or all doctors. So if it is all engineers, then it would be 5 engineers choose 4 or 4 doctors choose 4. The answer for that is 6. Okay, 3 doctors and 1 engineer. That means they are giving it very clearly. It will be 4 doctors choose 3 into 5 engineers choose 1, which is 4 into 5, 20. Why is it into? It is and. In each outcome we are multiplying because, for example, it is in this we have 2 engineers and 2 doctors. So 5 choose 2, 5 engineers choose 2 into 4 doctors choose 2. Okay. Number 19. How many triangles can be formed by joining the vertices of a hexagon? What is a hexagon? It is a 6-sided figure. It is called a polygon. Means it has more than one side, more than one vertices. So 1, 2, 3, 4, 5, 6. 6-sided hexagon. So from these 6 points or vertices that we call, how many triangles can be formed? We can form one here, then how else can we form a triangle? Maybe one like diagonal here and here, right? So we have to choose 3 points all the time to form a triangle because a triangle has 3 vertices. These corners are called vertices. So we have to join 3. We always have to join some points. We always have to join 3 of these vertices in order to get a triangle. So 6. Do we care about the order? No. This is a combination question. So it will be 6 vertices, choose 3. Which the answer for that is 20. Understood? First understand the question. Next, there are 16 points in a plane, no 3 points of which are collinear. Find the number of straight lines and number of triangles. What do you mean by collinear? Collinear means all the points fall on the same straight line. So here we have 16 such points. No 3 points are collinear, meaning only 2 points at each time fall on one straight line. For example, there's on one straight line. For example, there's one here, straight line number, this is a second straight line, and this is the third straight line. But we will never have a situation where there is another point here and there is one straight line joining 3 points. No, the straight line always joins the 2 points according to this question, because 3 points are not collinear. Only 2 points are collinear. This is called collinear, meaning all points fall on the same straight line. So, and for a straight line, we only need 2 points. So from the 16, we have to choose 2 points, 2 points, 2 points. How many such straight lines can we form? It is a combination question, not permutation. We don't care if it's an arrangement. We don't care whether this is the first straight line. We don't want to know whether this is the first straight line. Sorry, I don't mean to say don't care, but we don't want to know whether this is the first straight line or second straight line. This is a combination. So it will be, number of straight lines would be, this is actually 16. It's a typo. 16, choose 2. 16 points, from 16 points we have to choose 2. The answer is 120. For number of triangles, same ideology. 16 points are there. From that we have to choose 3 to form a triangle. In how many ways can we do it? 16, choose 3. This is not 6, it should be 16. Answer is 560. Right. Number 21. A bag contains 2 white balls, 3 black balls and 4 red balls. In how many ways can 3 balls be drawn from the bag? Again, is this a permutation problem or combination? Have they said anything about order? No, they're only asking us to draw 3 balls from the bag. Did they say we first have to draw white ball, then black ball, then red ball? No, simply we have to draw 3 balls. So there's no order. Then it is a combination question. How many balls are there in total? 2 plus 3 plus 4 is 9. How many should we draw? 3. So it is 9, choose 3, which is 84. Okay, so understand the question first. Number 22 is similar to the different scenarios that we did in number 18. So please try it out yourself. It's the same similar concept, so do it yourself. Number 23. If Np4 is 360, what is the value of N? So here we have to do some work. 360 can be, first find the factors of 360. Okay, we got it as 2 into 2, 2 into 3, 3 into 5. So 2, now from that try to form a factorial. For example, 2 into 2 can be written as 4, 3 into 2 can be written as 6, then you have 3 and 5. So you have 6, 5, 4 and 3, which is 360. So 4 and 3, which is 360. So 6p4 is equal to 360. So something p4 is equal to 360. So n can be given as 6. Okay. So you will say 6 factorial means 6 into 5 into 4 into 3 into 2 into 1. That is the correct way. But that 2 would have been cancelled off in the calculation. How do you know that? You have to do some trial and error. Okay. For example, say Np4 is equal to 360. This means n factorial divided by n minus 4 factorial is equal to 360, right? So n factorial divided by n minus 4 factorial is equal to 6 into 5 into 4 into 3 into 2 into 1. This can be written as n factorial and n minus 4 factorial is equal to n into n minus 1, so on. You have n minus 4, n minus 5 into, right? At the bottom you have n minus 4 into n minus 5, so on. So this gets cancelled with this. So here on the top we are left with n into n minus 1 into n minus 2 into n minus 3 is equal to 6 into 5 into 4 into 3, right? Which can be written as 6 into 6 minus 1 into 6 minus 2 into 6 minus 3. Therefore n is equal to 6. Understood? 2. Okay. Alright. There are 40 students in a class, number 24. If all students shake hands with each other, then how many shake hands did happen there? First of all, is this a combination or permutation question? Are we concerned about the order or arrangement? No, we are only concerned about shaking hands. It doesn't matter whether me and you shook hands first and then Ram and Sita shook hands? No. So it is a combination problem, right? How many people do we need to shake hands? 2. So from 40, there will be 2, 2, 2, 2 each shaking hands. How many such ways are there, or how many shake hands happen? 40 choose 2, which is 780. Or you can use this formula, but better to do this way so that you understand better. Okay. Number 25. In a class, all students shaked hand with each other. Okay, if 105 shake hands happened there, then how many students were there? So this is the opposite of the first question. For that, we just have to take n into 2 and the nearest square. So n here means number of shake hands. So it's 105 into 2, which is 210. What is the nearest number which is a perfect square? It is 225. And square root of that is 15 students. So number of students were 15. Now how will you know this? This you will know only from your practice. Remember I told you to study the squares and the square roots and the cubes and the cube roots of numbers 1 to 25. This is how you will come to know. This is where it will help. Okay, so please do that. Don't forget what we have studied. This is a formula. You'll have to memorize it for this question. Number 26 is similar to this, so please do it yourself. Number 27. 5 books are kept in a bookshelf. In how many types or ways can it be arranged? So is this a permutation question or combination question? It is a permutation question because order matters. Suppose if I have book 1, okay, book 1, book 2, book 3, book 4, book 5. I can arrange it in different ways. It can be book 1, book 2, book 3, book 4, book 5. Or it can be book 2, book 1, book 3, book 4, book 5. So it is 5p5, which is nothing but 5 factorial, which is 120. You can also simply write 5 factorial because factorial shows you number of ways of doing something. So here it is simply 5 books, and ways of arranging 5 books is nothing but 5 factorial, which is 120. Okay. Number 26. Number 28. 6 children are around a round table. Okay, 6 children are sitting around a round table. How many ways or how many types can they sit around it? For that we have to use a formula. It is not n factorial because it is a round table. So it is n minus 1 factorial, right? So it will be 5 factorial here, which is 120. Why is it n minus 1? Because of the seating arrangement. It's a round table, no? So you have 1, 2, 3, 4. How many people are there? 6 people. So this is one way of doing it, right? Then you can have, this is the head of the table. You can have 2, 1, 3, 4, 5, 6. Because it's a round table, we use the formula n minus 1 factorial. Okay. So this brings us to the end of this lecture. I hope you guys are practicing and following it. Please practice more. Without that, you can't do anything. Know the formula, and I'll see you in the next class. Until then, all the best and take care.